Okay. So, good evening. Good evening, one and all. Welcome to this wonderful webinar session conducted by Pantech e-learning and Velalar College of Engineering and Technology. So, today we are going to see about how we can use deep learning and then artificial intelligence. Okay. So, before we enter into this webinar, I like to thanks to Velalar College of Engineering and Technology, all the faculty members and then HOD members, HOD and then college also. Okay, so thank you for the conducting this wonderful webinar. And here with the Pantech solution, we are conducting national level 5 days industrial training program. It's all about domain knowledge. Okay, so like we have different type of domain knowledge. So we are conducting this. It's organized by Pantech e-learning and Velalar College of Engineering. So it's all about future scope of engineering in global development. Okay. So let me enter into the session. Before we enter into the session, I like to introduce myself. I am Kamlesh. I am from Pantech e-learning, and I am very glad to take this webinar for Velalar College of Engineering and Technology. Why? Because it's my own city, Erode. So I'm taking. So thank you for this wonderful webinar. So let me enter into the session and we'll start how we can do it. Okay. So deep learning and artificial intelligence. So before I will like to tell the goal of today. Okay. So today I will just introduce you to Keras, and then I will not teach about all about Keras, but I will teach something about Keras and you will learn, okay, what is the use of Keras. Okay, so Keras is nothing but it's a library package of Python. Okay, so this is the agenda is nothing but overview, intro to Keras and TensorFlow, and then introduction to deep learning algorithm, and then Keras in depth and conclusion. Okay, so note one thing, after this agenda I will move on to technical session. Okay, so how we can build a simple neural network algorithm, and then how we can predict a diabetes patient. Okay, so I have already data set of diabetes patient details. Okay, so how we can do the technically, okay, technically how we can use Keras and how we can build a neural network algorithm, I will explain you. Okay, so this is the thing we are going to see in this today's webinar session. Okay, so let me enter into the session. Hope be ready with fresh mind. Okay, so let's go. So first of all, overview is nothing but about comparison between machine learning and deep learning. Okay, so if you are always the deep learning versus machine learning, okay, always you guys will something confusion. Okay, so here we will clear about that. Okay, so here you can see I am having an input of car. Okay, input of car means we have like size, shape, color, weight. Okay, so attribute. Okay, so for car we have some attribute. Okay, so based on that attribute, if you want to train a machine learning type of algorithms, we need to do feature extraction and then classification, and after that we will comes to know whether it's a car or not. Okay, but if it is a deep learning type of algorithm, we don't need to do any feature extraction. Okay, then give the output result. Okay, but the way of training a machine learning algorithm and the way of training a deep learning algorithm is totally different. Okay, so the way of training a machine learning algorithm is like using some formulas or using some regression line or using some support vectors, we can predict the output. But the way of training a deep learning algorithm is different. Okay, so deep learning algorithm is like our human being. Okay, so as a human being we will act based on neurons, right? So our brain have more number of neurons. If you want to do some action, okay, we using that stimulation of neurons, we are doing that action, right? So like that same thing only we are doing with deep learning algorithms. Okay, so deep learning algorithms have some neurons. Okay, based on that neurons it will be act and give the output result. But how you can build the neurons? here one question is there, right? How you can build the neurons? So that is what today's session we are going to see about Keras and TensorFlow. Okay, so Keras and TensorFlow is the library package to build a neural network algorithms. Okay, so to build a neural network algorithms, otherwise to build a neurons. Okay, so that is what we are using here, Keras and TensorFlow. Okay, so generally neural network algorithm is like a non-linear machine learning model. Okay, so it's not a linear machine learning, so it's a non-linear machine learning model, and then it will be supported for both supervised learning and unsupervised learning. Okay, so supervised learning and unsupervised learning is nothing but like if you take a supervised learning type of data set, we have a data with output. Okay, we have a data with output. For example, in today's session also I will take an supervised learning type of data set only. Okay, so we have a data of patient detail like age, gender, and then blood group, and then blood pressure level, like that. I will take some data of the patient detail, and then I have a one column. Okay, so data set is nothing but we have like it's, you think our Excel sheet. Okay, so Excel sheet consisting of more number of rows and columns, right? So like that only data set also available. We have more number of rows and columns. Okay, so otherwise I will show you. Wait a minute. So here you can see this is our data set. Okay, so data set is all about glucose level, blood pressure level, skin thickness level, insulin, BMI, okay, diabetes, and then age. Okay, this is an data set. Okay, the diabetes data set. This data set is downloaded from online only. We have a website like UCI, and then Kaggle website, KAGGLE. Okay, Kaggle website. Based on the website will be give some open source data set, so we are using that downloading from there only. Okay, so if you want this data set, in description I will give the code and link also. Okay, in description I will share the code and link also. You can use that link, you can download the data set, both code also of this today's session. Okay, so here you can see this is the data set. Okay, so here we have a column called as a outcome. Okay, so what is the difference between supervised learning and unsupervised learning is, the supervised learning is nothing but if you have an output column. Okay, that is output column is nothing but for this data. So here it's having a this row represent one patient detail, and this row represent one patient detail, and this row represent one patient detail. Okay, each and every row represent one patient detail. According to the first row I am here outcome 1. Okay, 1 is nothing but the patient will be attacked by heart disease. Okay, attacked by diabetes. Okay, but if you having a 0 here, that outcome will be a 0. The patient will be not attacked by diabetes. Okay, so this is the output column. So the 0 represent not attacked by diabetes, 1 represent attacked by diabetes. Okay, so here we have some data about patient, and then we have an output, that is called supervised learning. Okay, if it is an unsupervised learning, we don't have this column, only we have a data. Okay, so this is an if you have like that data set, that's called as a unsupervised learning. Okay, so here our deep learning algorithm will be supported for both supervised learning and unsupervised learning. Okay, so let me comes to the deep learning, how it's work. Okay, so deep learning is nothing but it's consisting of input layer, hidden layer, and output layer. You can see the picture in the presentation. Okay, so we have a input layer, hidden layer, and output layer. So this is the called as a deep learning. If it is the hidden layer have more number of layers, that's called as a deep neural network. Okay, so if hidden layer consisting of only one, like that means it will be simple neural network, and you have a more number of neural network, it's called as a deep neural network. Okay, so where we can use deep learning? Okay, so we can use deep learning like MATLAB. Using MATLAB software you can build a deep learning algorithms. Using PyCharm you can build a deep neural network algorithms. Okay, so these are some of the softwares you can use. And then introduction to Keras. Okay, so this is the important thing. Okay, so now just we see about deep learning algorithms. Next we see about introduction to Keras and TensorFlow. Okay, so if you want to build a deep neural network algorithms, we need Keras and TensorFlow package in your Python. Okay, so this is important. Okay, so here we will see about what is Keras. Keras is nothing but if you want to build a neural network algorithm like this. Okay, like this you want to build input layers and then hidden layers and then output layers. We need some framework. Okay, so that framework is called as a Keras. Okay, so that framework is called as a Keras. If you want to build a deep neural network or neural network algorithm, you need to use this Keras package. Okay, so Keras is nothing but it's a API. Okay, it's a API for build a neural network algorithms. Okay, so it's just using Keras you can just build a neural network algorithm, but you need to create the neurons. Okay, you need to train the neurons and you need to test the neurons. That and all will do it with TensorFlow. Okay, so that and all we will do it by TensorFlow. Okay, so TensorFlow is the package. Okay, if you want to train the algorithm or test the algorithm, you need to use the TensorFlow package or Theano or CNTK. So these are the some of the packages for training and testing the deep learning algorithms. But Keras is nothing but it's to just we need to build an algorithm. Okay, but if you want to train and test the algorithm, we need TensorFlow package. Okay, so here you can see the comparison of we have different type of packages. Okay, like in Python, TensorFlow, PyTorch, Keras and FastAI, this and that. But most popular combination is TensorFlow and Keras only. Okay, so the after that only PyTorch. Okay, so TensorFlow is introduced by Google. Okay, so Google is the first introduced by TensorFlow. So based on that only we are developing the code, and then where we can use when we can use the dataset. You can, if you are new to beginner of the deep learning algorithm, you can use this Keras and TensorFlow and you can build the algorithm. Okay, so if you are want to do any fundamental research purpose, you can use Python plus TensorFlow or PyTorch also. Okay, so here you can see the TensorFlow. About TensorFlow, the TensorFlow is a library invented by Google only. Okay, so the TensorFlow is nothing but it's having a multi-dimensional array object. Okay, so it's having a multi-dimensional array object. The TensorFlow will be built by C++ program, and then it will be used for both CPU and GPU. Okay, so this is all about TensorFlow. And then we just introduction to deep learning. Okay, so what are the algorithms will be available in our deep learning, and what algorithms we will use in today's session. We will discuss about this. Okay, so if you take a deep learning algorithm, they have major popular 3 algorithms will be there. Okay, one is one is like artificial neural network, another one is deep neural network. In deep neural network we have some of the popular algorithm like CNN, convolutional neural network, and then RNN, recurrent neural network. Okay, so before that I need to explain how deep learning algorithm will be works. Okay, so better I will take paint. Okay, so then you will be understand. So same thing here you can see. So here I am taking a data, that is input data x1, x2 and then xn. Okay, so I am having a input data. So I already told you, if you want to build a simple neural network, we need input layer, hidden layer and output layer, right? So I will build, first I will build a input layer. Okay, so input layer is nothing but we need to pass our dataset value to the input layer data. Okay, so this is input layer. Okay, so x2 will be passed to all the neurons. So these are all neurons. So all the neurons I am passing the data. Note one thing, if you take an x1, the x1 will be connected with all the neurons. Okay, so that is called fully connected layer in deep neural network. Okay, so if x1 if you take a x1 data, x1 will be connected with all the neurons. If you take an x2, it will be taken to the all the neurons, and x3 will be taken to the all the neurons. Okay, so it will be connected with all the neurons. Okay, so after that I will introduce it into hidden layer. Okay, hidden layer. Okay, so hidden layer is nothing but after I am passing my all the data to the input layer. Okay, then I will pass into the hidden layers. Okay, so hidden layer will be do some hidden layer consists of some activation function. Using that activation function, I will do some process. Okay, to find an output. Okay, according to our data set, so we need to predict whether the patient have diabetes or not. Okay, so this is our main aim, right? So here I will pass the patient detail, then import to the input layer, then input layer will be passed to the hidden layers. So hidden layer will be pass some data, and then it will be give the output. Okay, so whether the patient will be attacked by diabetes or not. Okay, so this is the thing we are doing here, but each line have some unique weight. Okay, each line have some unique weight. Based on that unique weight we will act. Okay, neurons will be act. Okay, then next, this is all about artificial neural network. So artificial application, okay, where we can use like computer vision or speech recognition or machine translation, social network, filtering, medical diagnosis. Okay, so today we are going to see about applications of medical. Technically we are seeing about medical diagnosis. Okay, so these are the area we can cover of ANN. Okay, then next one, deep neural network. Okay, so deep neural network is nothing but here you have only one hidden layer, right? But if you have a n number of hidden layer, that is called deep neural network. Okay, so in deep neural network we have like different type of algorithms like CNN, RNN. Okay, so CNN is one of the most popular algorithm to train the image. Okay, so here my dataset in the form of Excel sheet, we can easily train and we can easily test the algorithm. But if you have a data set in the form of picture, like for example you can take your mobile phone. Okay, so you have face unlock. Okay, so the face unlock will be done by using pictures, right? So you are giving some input as a picture. Okay, for that input as a picture you are getting an output, means we need to use some other advanced algorithm. Okay, so one of the advanced algorithm for training a picture and getting an output is CNN. Okay, so convolution neural network. Okay, so about deep neural network is nothing but it's fully connected layers. So already I told you about fully connected layers, and then this and all. Then next we enter into the types of deep neural network. So we have RNN and CNN. Okay, so first we will see RNN. RNN is nothing but for example, can you take it as a stock market price prediction, right? We have stock market. Okay, so stock market values will be there. The day by day the stock market value will be increase or decrease. Okay, we can't predict exactly, right? Today values will be low, or someday the values of the responded company will be increased. Okay, we can't predict exactly what is the stock market values. Okay, so for that purpose we can use recurrent neural network. Recurrent neural network will be learned from past data and present data, then it will be give the prediction value of future data. Why I suggested you to use recurrent neural network means, compared to all the algorithm in RNN we have a memory space. Okay, so using that memory space only RNN algorithm will be learned, and then it will be predict the output. Okay, so that is the one of the main advantages of RNN neural network algorithm. Okay, then next one, convolution neural network algorithm. Okay, so convolution neural network algorithm is nothing but, I already told you, if you want to train the image, okay, you can use this convolution neural network. Okay, so you can see here I am having on input image one robot. Okay, so first what it will be do what the algorithm will be doing means it will be take some important part in your input data. Okay, so important part, and then it will be do some sampling, and then it will be converted into one image. Those image it will be take some important value, and then it will be converted into some sampling, and then we will predict a output. Okay, so that is the use of convolution layer. Okay, so mostly convolution will be used for visualizing an image or open CV, open computer vision, like in your mobile phone. I told you now already, so like that example, and then speech recognition, and then recommendation system. NLP is one of the main, okay, natural language processing. You are using Hey Siri or OK Google, like that things and all. Okay, so you can do, for that purpose you can use NLP, natural language processing, or Google Translator, or some other applications we are using. So this and all based on NLP. So Keras in depth. Okay, so let me conclude the presentation up to this. Okay, then we will be move on to technical session. Okay, so Keras in depth is nothing but we have lot of things. Okay, so now for example, from starting, if you are downloading a dataset, after downloading a dataset from online, what you have to do up to ending. Okay, so this is the steps you need to do. Okay, like data representation. Data representation is nothing but we need to check whether the data set will be in the form of integer value or categorical value. Okay, if you have a categorical value, what you have to do. Okay, that will be comes under data representation utils. Okay, after you do that conversion of integer or float value, you need to move on to sequential model. Okay, sequential model is nothing but to build a neural network algorithm. Okay, if you want to build a neural network algorithm, you need one area, right? You need one model. Okay, so within that model only you have to train and test the algorithm. So for that purpose I will use sequential model. Then class API. Okay, so class API is nothing but we need to connect with some other library packages also, like TensorFlow. If you are using Keras means automatically it will become TensorFlow as a backend. Okay, that I will show you that and all. Okay, then Keras layers. Layer is nothing but like convolution layer. If we are seeing about CNN. Okay, so if you want to do with CNN type of algorithm, you need convolution layer. Okay, so if you want to do some simple neural network, you need dense layer. Okay, so we got different type of layers also available, and then activation function. So this is important. Activation function is an important one. Why means if you take a data set, raw data set, we have only a weight of that raw data set, right? So based on the weight we can't predict the output. Okay, we need some cost. Okay, we need some cost function. Okay, using that cost function only we can predict the output. So this is the activation function is one of the major play a role in our deep learning algorithm. Okay, then loss function is why we are using means deep learning algorithm not like a machine learning. Okay, so machine learning just what we are training the data, it will be give the prediction output. Okay, that is just vomiting the output. Okay, but if you take a deep learning algorithm, it will be learned from errors. Okay, so we have a loss, based on the loss value it will be again train the algorithm and then give the output. Okay, so loss function will be supported by optimizers also. Okay, so optimizers here, and then learning rate schedule, metrics, we can find the accuracy score. Okay, like that we can do all the process with Keras. Okay, so next I will do this process like preparing a data set. So we already have a data set of diabetes patient. Next I will build a layer. In that layer I will compare the layer and fit the model and evaluate the model. I will do this in technical session. Okay, so if you are ready to do, follow me, you can, it's easy only. Okay, so if you are CSE or IT student, it's easy. And then some other, if you are no programming language, you can follow what I am doing. You can build down simple neural network. Okay, so for that purpose you need online. sorry, you need browser. Okay, so okay, search it for Google Colab. Okay, so if you are searching Google Colab, you will be get on result. Okay, so in this result you need to choose this notebook. Okay, go to Google Colab and then click this, just search it for Google Colab and then click this icon, this notebook icon, then automatically it will be enter into another one page. That page will be consist of like some information about your Google Colab, and then how we can upload the data set, that and all we can do it in our like this. Okay, so it's loading. So already I created my untitled IPynb file. So if you want to create means you can use like this, file new notebook. Okay, so if you are giving like this, it will be created a new notebook. Okay, in this new notebook you need to upload our dataset. That is, I already showed you diabetes dataset, right? So we need to upload this dataset to our Google Colab, right? So I already uploaded. If you guys want to again do with this means, you can use that description link and download the dataset and then upload it in Google Drive. If you want to upload, use this button. Okay, if you use this button means automatically it will be asked which file you want to upload. Easy, after downloading your dataset, you just click your dataset name and then upload it down. Okay, so now I have a Google Colab. With using this Google Colab, I will tell you how to create a simple neural network algorithm. Okay, so this is the way. Okay, so first of all I need to I need some packages, right? So packages like basic packages like import numpy. Numpy is nothing but np. Okay, import numpy as np, and then otherwise you can use this also, from numpy. Okay, import load text. Okay, load text. Here you need to know what is numpy, right? Numpy is nothing but it's a numerical Python. Okay, if you want to build an array value, or if you want to build some other numerical functions, if you want to do some numerical calculation or mathematical calculation, you can use numpy package. So numpy is the package, it's available in Python. Okay, so it's an inbuilt function only. Okay, so here I am loading my numpy package. Okay, so first of all you need to know what is Google Colab, right? So Google Colab is nothing but it's an online tool. Okay, we can execute our machine learning or deep learning code in this tool. Okay, so we have, like, if you open Google this if you open Google Colab, you will be get like this only. So here we have plus code symbol to increase the cell. Okay, so if you want to increase the cell, you can give. Note, if you take a Java program or C++ program, we have continuous, we need to compile a single run, right? We have one full, we will type all the code and then we will run the code, then we will see the error or output. Okay, but here it's totally different. We can run the code line by line. Okay, line by line we can run the code. That's why it's called as a interactive Python notebook file. Okay, so that's why it's called as a interactive Python notebook file. So here I am running the cell from numpy import load text. After running the cell, I am typing the code data equal to, here I am having a dataset, right? So diabetes clean.csv. I already showed to you. Okay, so what is that dataset? So here I am reading my dataset. Okay, using load text function, I am reading my data clean, that is diabetes clean.csv. Then here I am using delimiter. So delimiter is nothing but just I am separating my file. Okay, separating my data using commas. Then I am running the cell. Then after that I am print the data. Okay, print the data. You can see the output. See, so the data set which I showed you in this Excel sheet, all are read by using Google Colab, all are reader. Okay, so this data set here 6, 148, 172, 35, same values here we have 6, 148, 72 like this. Okay, so now I reader my diabetes patient data set. So now I will build the neural network algorithm, and then I will train the neural network algorithm. Then I will test the neural network algorithm whether it's giving prediction result correctly or not. Okay, so for that purpose I will first of all I will create a new two variables, that is x and y. So x represent all about data. Okay, so here in data, okay, I will take like this, and 0 is to 8. Okay, in here I am using data, then from starting to ending, then 8. Okay, so I will tell you what is the use of this code. Here x always save my data. Okay, so data is nothing but this one. Okay, from pregnancies to age, I will save these all the data up to age. From starting here to here, I will save this all the information into x variable. In y variable, I will take only this output column. Okay, so the outcome. Okay, so I already told you 0 means not attacked by diabetes, 1 means attacked by diabetes. So I will save the data set or that column in y. Okay, so that is the here in y we have outcome. Okay, so this represent why I am giving 0 is to 8 and 8 is, if you take a data set, this is the index value. Okay, so here in Python this is called as a 0, this is called as a 1, 2, 3, 4, 5, 6, 7, 8. Okay, like that I am giving. So starting value is 0, from 0 to 8. Okay, 8 means always last one should be n minus 1, that is up to 7 it will be saved in our x, up to 7 index value it will be saved, and then I will save only 8 in this. Okay, so that is what here we are doing. So I am running the cell. After running the cell, I will create a new code cell. Okay, in this new code cell I will do next process. Okay. Next process is, just wait a minute. Everything is perfect. Okay, so from SQL I am importing a model selection, then import train and test bit function. Okay, so train and test bit function is nothing but, here I am having a data set, right? This data set will be divided into two types. One is train data, another one is test data. So for that purpose I am using this train and test bit function. Then I am creating a new line. In this line I will create a 4 variable, x train, x test, and then y train, y test. Okay, y train and y test. So here I am calling the train and test bit function. Train and test bit function. Within this function I will pass the x data and y data. Okay, so x data and y data I am passing here, Then after that I will give the test size, how much we need to split the test size. Okay, so test size should be 0.2. okay, so 0.2 means 0.2 means 20 percentage. okay, if it is an if you are giving 0.3 means 30 percentage according to the this train and test fit function. okay, so here I am giving test size equal to 0.2. so totally we have a data in our data set. Totally we have wait a minute. So here you can see totally we have 768 patient details. okay, in this 768 patient detail, randomly 80% will be stored in train data and randomly 20% will be stored in test data. okay, so that is the use of xtrain and train and test fit function. okay, here I am running the cell. After running the cell, I am creating a new cell and then I will enter into the, you can see here xtrain. I will enter into the building a neural network algorithm. okay, building a neural network algorithm. okay, so everything is I done. okay, now it's ready. I will pass the train data to the algorithm to train the algorithm and test data to the algorithm to test the result. okay, so I am building the neural network algorithm. so how means I already told you, if you want to build a neural network algorithm, we need one model. okay, so what is that model name? Sequential model. In PPT I explained you, right? so I am importing that model in Keras. I am importing a models. The model name is called as a sequential model. okay, then after building a sequential model, in next line I will save my sequential model into one variable. okay, so variable name is called as a model and then here I am save it in sequential. okay, so just I am saving my sequential model into models. okay, now I will create a new cell using this. I already told you we have input layer, hidden layer and output layer, right? So we will do this one next in coding wise we will create this one. okay, first we need input layer, right? so I will type a code for input layer. Using that model I will type a code for input layer. so model dot add. okay, in model I am adding an input layer dense. okay, so dense is the layer that is input neurons. okay, dense is nothing but it's a neurons. so first of all I need to see the shape of the dataset, right? so after I am reading I didn't check the shape. okay, we need to check the shape because based on the shape only we need to build a neurons. so here I am checking the shape. okay, so what is the shape of the our data set is 768, 9. That is totally we got 768 rows and then 9 columns. okay, so 9 column shape means we need to build an input layer 9. okay, 9 neurons. okay, that is the use of shape. okay, so here I will build a 9 neurons. okay, not a 9 from 0 to 8 means totally 9 neurons, right? so here I am building a 9 neurons. okay, then after that I am giving the input shape. okay, input underscore shape, input dimension how much? Same 8. okay, so just nothing I am doing here. so first layer in neural network first layer is input layer, right? so here I am creating an input layer with 9 neurons. okay, so that is the thing we are doing. Next thing we need to build an hidden neurons. okay, that is the next line code. so we builder here and I am here using activation function. Okay, so AAC model, sequential model, and then in model I will use activation function. ACT activation function. So activation function is always ReLU. Okay, so ReLU is one of the most important function. Sorry, some of the most popular activation function. Okay, so I am using here ReLU. Okay, model dot add activation function ReLU. Okay, so here dense is not defined. Okay, so we need to import dense layer, right? So here I am getting an error, dense is not defined. We need to import also dense layer because we just import an sequential layers. Okay, we need to import dense layers. So in Keras I am importing an layer. The layer name is called as a dense, right? So layers import dense layer. Okay, then we will check it, we will run the code. It's executing, dense is not defined. Okay, we need to run this line and then again we need to run this code. Okay, so that is what we need to do. So here after dense layer, that is now I created an input layer. Next I need to create a hidden layer, right? So here I am using model same add and then dense layer. Within this dense layer I am passing the output. Okay, so I need to tell one thing. Here I am, my input dimension is 8, right? So input dimension is x1, x2, x3 up to 8. I will have input neurons. Okay, after I am passing the input data, definitely I will get an output 8. Okay, output layer also output also 8 data value I will get. So for that purpose in hidden layer also I will creating a 8 neurons. Okay, so that is the use of next line. Okay, so here I am using 8 neurons with activation function. So activation function is all about same function only, ReLU. Okay, so ReLU will be applicable only for input layer and output layer, input layer and hidden layer, but not useful for output layer. Okay, so for output I am using here model dot add and then here we are adding a dense and then within dense I am passing the output layer. So output, what we have to predict, whether the patient have diabetes or not. If the patient have diabetes, we need to predict 1. If the patient have not diabetes, we need to predict 0. Okay, so only one neuron is enough for this. Okay, so only one is enough. And then here I am using activation function something different. Why means we need to predict the binary type of value, whether 0 or 1. Okay, 0 or 1 means binary type of value. So for that the sigmoid is enough. If you want to predict the binary type of sigmoid, if you want to predict binary type of output, the sigmoid activation function is enough. Okay, if you want to predict like a more number of classes like 0, 1, 2, 3, we need to predict. Okay, so for that purpose you can use softmax. Okay, softmax activation function. Okay, so here I build output layer, right? Output layer. Okay, so this is the thing we will done with. So we now created one neural network. Okay, using the Keras we created a neural network. So it's successfully run, then successfully executed. Then next we will move on to next step. The next step is all about building an compiler. Okay, so now we create a neural network algorithm. Now we need to build a compiler. So for compiler, using model dot compile function. Okay, so compile function, within this compile function I am using last function. I already told you about last function and optimizer. Okay, so optimizer and last function I am using here. Then I will use accuracy score, that is important, right? Metrics. In metrics I am using accuracy score. Okay, accuracy score is nothing but how the way of training algorithm, how it's performing. Okay, how it's performing that training. Okay, that is the use of accuracy score. Okay, so accuracy score and optimizer. Here last function we need to use last function, like it's a sigmoid, right? So sigmoid means it's a binary. We need to predict the binary values only. Okay, so for that the binary optimizer, binary cross entropy is enough. Binary cross entropy. Okay, so another one add-on function is enough. Okay, so here I am running the compiler. Now compiler also executed properly. Then it's time to give the dataset to train the algorithm. Okay, so to train the algorithm, if it is a machine learning or deep learning, okay, so you need to use the keyword not, you need to use the function fit. Okay, so fit is the function to train the algorithm. Okay, so if you want to test the algorithm, we want to use predict keyword. Okay, so here I am using fit function. Using fit function I am passing the data like train data, right? I already I splitted the train data and test data here. Here I already given x train data and y train data. So I need to pass this data within this function. So I need to pass those parameters within this function. So x train comma y train y train. Okay, so after this I need to do some other thing also, because in starting I told you if you want to build an if you want to train the deep learning algorithm, we need to give the data again and again, because deep learning algorithm will be learned from errors only. Okay, so for that purpose I am giving a data again and again. So the approach, okay, so approach is the thing we can using this approach we can, how many times you want to train the algorithm you can give. Okay, so here I am training the algorithm 150 times. Okay, 150 times it will be again and again iterate the data, and then we will get an output. Okay, then batch size, how much amount of data volume you want to give each and every iteration. So it's a random only, 55 anything you can give the output. Okay, so this is the use of fit. So fit is the key function to train the algorithm. Okay, so see here it's running. All my x train data and y train data will be passed to the my neural network algorithm. Then it will be started to train the algorithm. Okay, so this is the first iteration. Okay, in 150 iteration, this is the first. In first I am getting a last function 13.5. It's a huge. Okay, so last function is huge. It's giving a more value compared to accuracy score. We need to increase the accuracy score, right? So for that purpose I am giving 150. So if you take an last value of the last function and last value of the accuracy score, you will definitely get, it will be improved. Okay, so see here last value is 0.5 only, but accuracy is 0.74. okay, so almost it's reached to 75. So what is the use of accuracy score means algorithm learned properly. Okay, algorithm will be understand our data set 75% understand the data set. Okay, so that is the way we can use this model. Okay, model.fit. Now it's time to predict the output, right? So we have already data set, so we have, it's time to predict the output. So using that model dot using evaluate function we will comes to know what is the we will pass the test data. Okay, so we have test data, right? So we are passing the test data x test and y test, then I will get an output. Okay, so those output will be saved in I will get an accuracy result, right? So this accuracy result will be saved in one variable. So I am creating here one variable, accuracy equal to model dot evaluate. Okay, then we will print the accuracy. Print the accuracy score. So it's a final stage. So here we are getting the output 68%. Okay, so 68% we will the machine will be predicted correctly. Okay, in my test data we have some patient detail. So those patient detail, 68% of patient detail is predicted correctly whether they have a diabetes patient or not a diabetes. Okay, so this is the conclude of this session. Okay, so this is the output we are getting an 68%. If you want to improve the accuracy result, you can increase the delivery. You can increase the approach. Okay, approach iteration. Okay, so here I just explain you simple building a simple neural network only. Okay, so we have convolution neural network or recurrent neural network, that are all something different. Okay, here just a simple code only. Okay, so this is the thing. If you want this code, I already uploaded in our in my Google Drive. Then I will share the link in description. You can use that link, you can download it. And if you have any doubt regarding this webinar, you may ask it in comment section. I will explain you. Okay, if you have any doubt, not only for related to machine learning, not only for related to deep learning, machine learning or AI, anything. Okay, so if you have any doubt regarding this webinar, you may ask it in comment section. I will explain you. And then any questions? Okay, sorry, this one. What can we do with ML and what can so advantage of deep learning is, now if you have an minimum amount of data set, you can use machine learning type of algorithm. But if you have a more amount of data set, okay, the machine learning will not predict properly. So that's why we can use deep learning. Okay, deep learning will be do some other process with high. Okay, so that is the use of. Then is there any rules to have the number of hidden layers? Yes and no, not rules. Based on the data it will be changed. Number of hidden layers and number of output layers will be changed. We need to know about data set. Okay, how it's working and all. Any other questions from your side? I will explain you. Which language is preferred for deep learning? So now in my point of view, I will prefer Python only. Okay, so Python is enough. What is the difference between machine learning and deep learning? So if you want to train a machine learning algorithm, we need to do some feature extraction and then we will train the algorithm. But if you want to build a deep learning algorithm, we don't need to use any feature extraction. Directly you can build an algorithm, and you can build it. Okay, and then if you are new to this channel, you can please subscribe the channel and then hit a bell icon. Each and every day you will be get a videos when we are posting. And then if you are like this video, please hit a like button. It will be useful for us to give you like this knowledge more and more. Okay, so any other doubt in comment section? So already I have a code uploaded in Google Drive, and then I will share the link. You can use description and then you can check it out. So which tool is suitable for deep learning? So deep learning is suitable for, you can use Anaconda Navigator. Okay, here you can see Anaconda Navigator is one of the tool. It will be nice to use, and then you can use PyCharm or Python ideally. That is your wish. Okay, so deep learning algorithm were used for EEE department. Yeah, it will be used for all the site. Okay, so not only for department wise, all the department. Okay. Optimal value for approach based on the dataset size, it may change. Okay, so now here I am using an dataset, simple dataset only. So the optimal value will be we can, if you give an even 1000 also, it will be run easily. But if you take an image type of dataset, the training of one iteration takes so much time. So it will be take so much time. So the optimal value means based on the training time we will give. Okay, like that. How to use spider also we internal here we can't discuss. Okay, so okay, that's it. I will close this session at the end of. So if you have any doubt regarding this webinar, you may contact me on hyd.java@pantechmail.com. Okay, so you can contact me on hyd.java@pantechmail.com. If you have any, if you need like this if you want information, you can this channel for every upcoming events up to date. We will post it in the channel. And then if you need like this webinar for your college or for your college, if any faculty watching this webinar for your college, you need to sponsor like this video, you can contact Mr. Senjal Kumar, Mr. Srinivasan and Mr. Kumarasamy. They will help you. Okay, so thank you a lot for supporting this wonderful webinar. I hope everybody will understood how we can build an Keras and TensorFlow, using Keras and TensorFlow, how we can build a simple neural network algorithm. So I hope everybody will understood. So once again, thank you for the college, Velalar College of Engineering, and then faculty members who are organizing this program with the Pantech e-learning. Thank you for all. And then it's signing off from Kamalesh. Thank you all. Bye. Have a nice day.